Hey babies, get out your spirals. Let's take some notes for day 2 or 6.2, properties of rational exponents. We're going to start with adding and subtracting like radicals. Alright, simplify. Example 1. We've got the fourth root of 10 plus 7 times the fourth root of 10. So when we're adding and subtracting like radicals, it is exactly the same as combining like terms. We have the exact same radical here, the fourth root of 10, and we have the fourth root of 10 here. When you have exactly the same, again, it's just like combining like terms. Remember the coefficient that's secretly in front here. It is a 1. So essentially what we have is 1 plus 7. So that'll give me 8 fourth roots of 10. Example 2, we've got 2 times 8 to the 1/5 power plus 10 times 8 to the 1/5 power. Again, same thing as combining like terms. We're going to pretend that this is x. They are both exactly the same. So you basically just add the coefficients. 2 plus 10 gives me 12 times 8 and 1/5. If the two last names, if you will, if the last names are not exactly the same, you cannot add them. That would be like adding x squared plus x. We cannot do that. They have to be exactly the same. You combine like terms. Example 3. We've got the third root of 54 minus the third or cube root of 2. So again, remember I said these have to be exactly the same for us to be able to add or subtract them. These cube roots are not the same. We have the cube root of 54 and the cube root of 2. They are not the same. We cannot subtract them. What we can do is try to break 54 down. The cube root of 54 can be simplified. 54 breaks into 2 and 27. Now remember the shortcut that I taught you based on factoring. If either one of your terms is a perfect cube, you don't have to factor anymore. 27 is a perfect cube. The cube root of 27 is 3. So that gives me 3 cube roots of the only factor that's left, which is 2. So I've got this is the same as this, 3 cube roots of 2 minus the cube root of 2 right here. Now, since my radicals are the same, I have a cube root of 2 and the cube root of 2. Those are like terms. I can combine them. 3 minus 1 gives me 2 cube roots of 2. Okay, example 4. I've got the cube root of 5 plus the cube root of 40. Again, we cannot add these because our cube roots are not exactly the same. What we can do is try to simplify 40 and see if that allows us to be able to add the 2 roots. So 40 will break into 8 and 5. Now remember, if either one of these terms are a perfect cube, you can go ahead and take it out. 8 is a perfect cube. So this is going to give me, I'm going to rewrite this. So I've got the cube root of 5. And I'm going to add the cube root of 8 is 2. And what I have left underneath the radical is the 5. So I've got a cube root of 5 plus 2 cube roots of 5. Those are like terms. I can add them together. That gives me 3 cube roots of 5. If you want to go ahead and take these further down instead of stopping where I did, you will still get the same answer. For example, 40, that splits into 2 and 20. 20 splits into 5 and 4. 4 splits into 2 and 2. So I've got 2, 5, 2, and 2. Knowing it was the cube root, I had to have triplets, and I do. There's 3 2's right here. So that came out, and the only thing that was left in the radical was the 5, which was here. No matter how you factor it, you should still get the same answer. Alright, these properties can also be applied to variables. So let's write this table down. When n is odd, it's going to look like this. So you'll have n. We're talking about variables this time. So instead of us having a under the radical, we're talking about a variable. So I'm going to use x. When n is odd, your answer will always be x. And I will show you why. So let's say I have the 7th root of 5 to the 7th power. If you put that in your calculator, the 7th root and the 7 will cancel out. That's like saying, what is the square root of 2 squared? These guys will cancel out. So that will leave you with 5. If you don't believe me, put it in your calculator. Likewise, if we had the 7th root of negative 5 to the 7th power, our answer here, according to the formula, would be x, which is the inside number, negative 5. Now, when n is even, so again, it's going to look like this. The nth root of x to the nth power, it will equal the absolute value of x. Remember, absolute value is always positive. So with the odd ones, we had whatever x was is what our answer was, whether it be positive or negative. Whenever your n's are even, you will always have the absolute value. Let's look at an example. We've got the 4th root of 3 to the 4th. Put this in your calculator so that you can see the answer. 4th root of 3 to the 4th will equal 3. However, 4th root of negative 3 to the 4th power, you would think it would equal negative 3, but it does not. It is the absolute value of negative 3, which equals 3. Make sure you put those in your calculator so that you can understand where I'm coming from. The reason for this is a negative number raised to an even power is always going to be positive. Negative 3 squared will give me positive 9. Same thing, if anytime it's raised to an even power, it's going to turn out to be positive. So all of your answers in this case will be absolute value. They will be positive. Now, this only works whenever your index and your exponent are exactly the same. If they're different, it doesn't matter. If they are exactly the same, these rules apply. Alright, simplifying. Variable expressions. Okay. Example 5. Alright, I have the cube root of 64, y to the 6th power. Cube root of 64, y to the 6th power. Alright, so now we're not only breaking down numbers, we're adding variables in there. Let me show you how it works. Always check to see if you have a cube root of the number. There is a cube root of 64. You should see that or know it by now. Cube root of 64 is 4. And then to take the cube root of y to the 6th power, it's basically dividing. How many times does 3 go into 6? 3 goes into 6 2 times. Y squared. There's your 2 times. 4y squared is your answer. Example 6. We've got the 4th root of x to the 4th, y to the 8th. Okay, keep in mind from last class, this can be broken down. This is the same thing as doing the 4th root of x to the 4th over the 4th root of y to the 8th. Those are equal and you can break them down that way. Okay, we have the index and the exponents match here, and they're even, so we're looking right here. Your answer is going to be the absolute value of x. Basically, the 4's cancel out and you're left with the absolute value of x. Now the bottom portion, the 4th root of y to the 8th. Again, it's basically dividing. How many times does 4 go into 8? 2 times. Your answer is y squared. So the final answer is the absolute value of x over y squared. Oh, goodness. Okay. Next thing we're going to talk about is writing variables in simplest form. Okay, we're on example 7. Okay, for example 7, I've got the 5th root of 4, a to the 8th power, b to the 14th power, and c to the 5th power. So again, same steps as last time. We're going to try to take the 5th root of 4. You should know that we can't take the 5th root of 4. So the 4 will stay underneath the radical. You cannot take the 5th root of it. Now as we move on to our variables, 5 goes into 8 one time. So 1a will come out. But there will be 3 left over. 5 goes into 8 one time with 3 left over. So the ones that are left over stay underneath the radical, a cubed. 5 goes into 14 2 times, so 2 of them will come out as b squared. 5 goes into 14 2 times with 4 left over, so b to the 4th will stay underneath the radical. 5 goes into 5 one time, so 1c will come out. There are none left over, so there is nothing that will go underneath the radical. Your final answer will be a, b squared, c, the 5th root of 4a cubed, b4. Example 8. The 4th root of 48, a to the 11th power, b to the 4th power, c to the 13th power. All right, we cannot take the 4th root of 48, but we also can't leave it that way. 48 needs to be simplified. 48 breaks into 16 times 3. Again, you can look at these factors and see if either one of them are have a perfect 4th root. 16 actually does have a perfect 4th root. The 4th root of 16 is 2, so the 2 will come out, and what's left under the radical is the 3. Fourth root of a to the 11th power. 4 goes into 11 2 times. So I'll have a squared that comes out with 3 left over. The ones that are left over stay underneath the radical. 4 goes into 4 1 time, so 1b comes out. It does not have any that remain, so there's nothing left to put under the radical as far as b is concerned. 4 goes into 13 3 times, so c cubed comes out, and there's 1 left over. So your final answer, I'm going to write it again because that's kind of sloppy. 2a squared b c cubed times the fourth root of 3a cubed c. I just rewrote it. Don't let that confuse you. Okay. Example 9. I've got 14 x y to the 1/3 power over 2x to the, that's supposed to be an x, to the 3/4 power, z to the -6 power. Alright, so we basically did this last time. These are dividing numbers and dividing variables. Just in case, N-A-M-E. Multiply / divide, add / subtract. We are dividing, therefore we will need to subtract the exponents. That's what it tells us to do. However, anytime you're dividing coefficients, you divide the coefficients. So 14 divided by 2 gives me 7. Now I've got x divided by x to the 3/4. Again, we are dividing, so we'll need to take one step up and do subtraction. X, you should know by now, has a secret coefficient, not a coefficient, a secret exponent of 1. So I've got 1 minus 3/4. Y to the 1/3, I have no y's on the bottom, so it will remain y to the 1/3 power. And z to the -6, remember about negative exponents. If the negative exponent is on the bottom, the entire thing will shift to the top to give me z to the 6th power. So I'm left with 7x, 1 minus 3/4 is 1/4. 7x to the 1/4, y to the 1/3, and z to the 6th power. Okay, example 10. I've got x divided by the cube root of y to the 8th power. X divided by the cube root of y to the 8th power. Now from last class, you need to remember that we can never have any radicals in the denominator. We have to get rid of that. We have to rationalize it. So remember, we're going to multiply our equation by 1, essentially, but we need to get rid of this guy. Does 3 go into 8? It does, but I'll have some left over underneath the radical, and I can't have that. I need 3 to go perfectly into a number so that the radical will be eliminated. The closest number to 8 that 3 divides into is 9. So I need one more y to get 9. Remember, we have to do the cube root of y over the cube root of y because this is the same thing as 1. We have to multiply the equation by 1. You can't just randomly pick numbers to multiply by. The reason we picked 1 is because when you multiply underneath the radical, again, if we're here, one step up, that means we add the exponents. That's going to give me the cube root of y to the 9th power over x times the cube root of y. We just multiply it across. Now from what I just taught you, 3 goes into 9 3 times. So I get 3, y cubed, I mean. 3 goes into 9 3 times, y cubed, with none left over, so I don't have anything going in the radical. And then the top stays x to the cube root of y. Alright. Last thing is adding and subtracting variables. Make yourself a little side note for this last problem. You cannot have a radical in the denominator. That's bad math. Alright, moving on. Example 11. We've got 5 times the square root of y plus 6 times the square root of y. We've practically done this already. These are like terms. They're both the square root of y. That means we can add them together. 5 plus 6 is 11 square roots of y. Example 12, we have 12 times the cube root of 2z to the 5th power minus z times the cube root of 54z to the 2nd power. Alright, like I said, the cube root of z to the 5th power and the cube root of 54z, those are not the same. They are not like terms. So like we did at the beginning of the lesson, we can try to simplify one of them. Obviously, we can, let's start here. We've got 12. Cube root of 2, we cannot take the cube root of 2, so that 2 is going to stay underneath the radical. For the z, 3 goes into 5 one time, so 1z is coming out. 3 goes into 5 one time with 2 left over, so z squared will stay underneath the radical. Minus, alright, let's try to take the cube root of 54. There is no cube root of 54, so we're going to have to break 54 down. 54 splits into 2 and 27. Now remember, we're taking the cube root. If either one of your initial factors are a perfect cube, you can go ahead and take the cube root of it. The cube root of 27 is 3, so that's going to come out. And what's going to stay underneath the radical is the other factor, which is 2. Now as far as the z, the cube root of z squared, 3 does not go into 2. We cannot take the cube root, so the z squared will stay underneath the radical. The only thing we need to remember to bring down is this z that was there to start with. Now I have like terms, cube root of 2z squared and cube root of 2z squared. I can subtract these. 12z minus 3z gives me 9z cube root of 2z squared. Alright, last one. Square root of 9w to the 5th minus w times the square root of w cubed. Okay, first thing we need to do is try to take, we're working with the square root now, square root of the number. The square root of 9 is 3, so a 3 will come out. Remember, the secret index of the square root is 2. So 2 goes into 5 2 times. So w squared comes out. There's your 2 times. However, it goes into 5 2 times with 1 left over. So 1w will be left underneath the radical. Minus. This w is still there, so we're going to leave it. Same thing here. The index for a square root is 2. 2 goes into 3 1 time. So I've got another w that I'm pulling out. And the only thing that's left, 2 goes into 3 1 time, so and 1 left over. So 1w will remain underneath the radical. This gives me 3w squared, square root of w, minus w times w is w squared, square roots of w. Now again, these are like terms. I've got the square root of w, the square root of w, this is w squared, and this is w squared. So I can, I can subtract these. 3w squared minus w squared gives me 2w squared. And then we also have that square root of w there. Alright, that's it. If you were lost, rewind me, go at your own pace, whatever you need to do. Your homework is online. I'll see you when I get back.